Good evening, YouTube. I'm very excited to be here. I've got a great video for you. Part 3, the solution. Allow me to recap where we left off in video number 2. In that video, I showed you an equal part mixture by volume of saltpeter and sugar. And I also showed you the math used to solve what mixture we would actually have. The saltpeter's much heavier and the sugar's much lighter. So by volume, that's 2 or 3 to 1 in terms of weight. And here's the secret on that experiment. I did not mix those according to math. I only did the math to illustrate how you would do it. I mixed them ballpark, 1 to 1. This is alchemy. We just experiment. Say we didn't know. And where would we start? 1 to 1. 2 solids. Then I want to get a solution. And the key to this whole thing is in the word solution. You see, the word solution has many solutions. A mathematical solution and an aqueous solution. We let water solve the equation for us. Here I've collected rainwater. And look what we have. I stirred it gently. I didn't heat it or anything too aggressive. I treat water like an intelligent feminine force. I let it take what it wants and reject what it doesn't want. Stir it around. Stir it around. Give it time. It's rainwater. I like rainwater. It's nice to get outside. And also, the rainwater doesn't have minerals in it like tap water does. So I mixed it around, and look, out comes the junk at the bottom, what the water doesn't want. So I let the water be the solution. I let the water be the solution. And I want to point out that this pyrotechnic mixture is relatively safe in terms of handling when wet. Some are not. Some will function by harmony with detonation. This one doesn't. But you got to know about that. And why would I even bother with pyrotechnics? I mean, after all, they're dangerous, but after all, this is the internet, right? So it's exciting. So we'll do some pyrotechnics. And from that, we can learn other things because, for example, you have nitroglycerin, which is very powerful, but also a heart medicine because the nitrated sugar alcohols are vasodilators. So don't let one-trick pony syndrome get you on these chemicals. There's a lot they can do. And this idea of water being the solution is in keeping with the Hermetic principles, which I've been reading. And it's noted in there how water is a solve, a solution. It's not the only solution. It doesn't solve everything, but it solves some things. In addition to that, we have the main tenet of alchemy, which is as above, so below. But I've got to tell you, it's not exact. Take, for example, a molecule where you have the nucleus and the electrons, and you say, oh, great, the solar system is the same thing, but it's not exactly the same. It's similar. As above, so below, sort of, kind of, take it with a grain of salt. So in that keeping, in that tradition, I added a quantity of water that was suitable for this operation. I just ballparked it, about 70%, about 3 or 4-fold what the soil would be, because the solid represents earth and the liquid represents water, and I patterned it after the body of a human, 70% water, or the body of the earth, 70% water. So that's how we get that. That's how we do that. That's alchemy concept added to chemistry instead of just doing the math. You can see big titties and explosions on the internet all day long. But you're not going to get this. Live action chemistry. So, in addition to decanting this, which is a chemical term, I'm going to take this mixture and separate it into two different containers, okay? Over here, this one, and over here, this one will be our pure one. Now, in the pure one, I'm going to let it have as much time as it wants to form a nice crystalline structure. And why does a crystalline structure, why do I think that's better than a mathematical solve? Because when you have the water dry out and it forms a crystalline structure, it is the flame propagation through the geometry of the crystalline structure that accelerates or creates the burn effect of the pyrotechnic, not necessarily the exact mathematic ratio. So that's why I want to let water do as it will and form whatever crystals it will, and we'll burn those in a pyrotechnic experiment. Now on the other side here, the potassium permanganate, the dangerous chemical. Now I don't know if I told you about this. Maybe I did, maybe I didn't. It's getting late. But anyway, this chemical can strip the thumb right off your hand with enough force of the flame. Very dangerous. I've gone to the hospital because of this. But at the same time, we don't want to get rid of it because it's a water purifier. It could save, man, third world nations or emergency places that know how to use this. This $2 or $3 could treat thousands of gallons of water, kill parasites. And you can drink it. It tastes fine. You don't want to do it for a lifetime. It has manganese in it. You could build up manganese poisoning if you went nuts with it. But in an emergency, valuable. So if I take this sugar water solution and I add it to this, I can expect a reaction, a fire reaction. It'd probably burn a hole in the table, make a big mess. And I like this table. I don't want to do that. And I don't want to go to the hospital again. But one thing I've never seen anybody do is take the liquid form and add a small amount of the potassium permanganate to it. How much can we add? What's a safe amount? Well, again, in keeping with the Hermetic tradition of treating water like a lady, I know a lady that's very pretty. She's an artist. And when she gets mad, her face kind of starts to turn red. And that's when you know you better stop. So we'll look for a tell. When this fluid gets hot, we'll add a little bit, add a little bit. And when it gets hot, then we know we stop. And we're going to use this thermometer to do that, of course. We're doing chemistry and alchemy combined. We're not dumb. I'm not saying that if you do one or the other, you're dumb. I'm just saying. Let's use the best resources available, right? Of course. Set to Fahrenheit. Okay. Now, let's start with our pure mixture. Here we have the pure mixture. And by the way, this is live chemistry. I've never tried this before. I don't know what it's going to do. Okay. Let's pour it in there. Ah, perfect. Perfect. That's great. That's great. That's great. Okay, there we go. That's enough for the crystalline. Maybe a little more. Brilliant. Now that's going to be our keeper mix, our perfect, flawless crystalline structure as it dries out over the course of the next week. This one, it's going to be our dirty bird. We don't know what's going to happen, but we're going to do it anyways because this is the internet and people like explosions. Okay, and then there's a little trash in the bottom here. Let's just use all of it. We'll let that settle, okay? While that settles, I have one proposition for you, the viewer. You see this magic ball back here? To me, in this video, we're going to let this represent the Earth, okay? And the Earth has a sun going around it, right, around. It goes, and the people live on there, and they're fighting because they don't have enough stuff. Oh my gosh. Well, what does the world need? Does it need gold? Does it need explosives? No, probably not, because the rich are destined to find the gold, and the fools are destined to find the explosives. That's because we live in Texas, bro. Anyway, we can solve the world's energy problems because electricity can benefit man. So if we were to build a global power grid, and I know the word global freaks some people out, let's call it planetary, okay? Sans the idea of government, none of that, just mechanically. If you could have the Earth with solar panels all around it in a matrix where all the electricity is tied together, then the dark side of the Earth can get electricity from the light side of the Earth whenever it needs it. And we share electricity 24/7, 365. Well, that's the real solution. That's the real solution. And we have the technology. We have the solar panels. I have solar panels and such. This and that. But the thing is, they can be expensive. They can be hard to get. So my proposition to you, the viewer, is to take a voltmeter like this right here. And you get your voltmeter. Okay, set it to baby volts. Okay, check it out with your battery. Okay, look at here, my battery works. Okay, I got what is it? Okay, 1 point whatever. Running a little low, 1.4. Now what you want to do is, my proposition to the world here, expose a substance to light and then test it with a voltmeter. See if it has a photoelectric potential. Does this? I've never done this before. I don't know. Will it? No, nothing. Perhaps if it was in this metal, it would. Perhaps if it were coated and exposed to more sunlight and dried out, it would. Right? We're looking for the lottery here. Okay? The holy grail of DIY electricity is going to be some kind of a fluid. Possibly. That's cheap, easy to use, relatively safe. So if you're an amateur experimenter, I urge you to take up arms, get your voltmeter, and start checking things out, and maybe you can find the holy grail of electricity. Because if I can't do it, I'm just one guy, dude. If 100 people do it, we have a chance that somebody might discover something. It's like the chemical lottery. The only thing is, it's technology. So if one person wins, we all win. Now, for the last part of this video here, the dangerous part, because internet. I told you about the woman. I'm gonna check the water temperature. Maybe we can get it a little closer to the front row seat. By the way, this is fool's gold, iron pyrite. Have you guys ever seen this stuff? If you run this on a grinder, it just smells like fireworks. And it's pretty good. It's a pretty good substance. You got to ask yourself who the real fools are chasing after one kind of gold versus another. It's very, very good. Anyway, let's move this to the front. You can watch. Look out there, Charlie's going to get burned again. All right, we'll bring it front and center here. Okay. You probably can't see the reading, but I'll read it out to you. 76.6 degrees Fahrenheit. Yes, 76.4. Now, let's add a very tiny amount of this very dangerous substance to this mix. See what it does. This is how much I'm going to add, and that's probably too much. It's very powerful. Let's see what we can do. 74.6, 75. Okay, it's got to recalibrate. 76.4.5. Add a little. Let's see. It's dropping. 76.3. We're okay. She's not mad yet. 76.4. She's not angry. She doesn't care. Look at that cool color though, huh? Let's add some more. Now we're adding way too much. Look at there. I told you this stuff is dangerous. 76.4. Stir around. What's happening? 76.4, it's holding steady. Maybe add a little more. Boom. 76.4. I'm going to add until I get a temperature rise, and then I'm going to stop. And then when this thing dries out, I'm going to let it dry out 1,000 miles away so that it doesn't explode while it dries out. Well, that's a lot. 75. Is this boring to you? I hope it's not boring. You know there's other channels with boobs and explosions. It's okay to be the Bob Ross of alchemy. I just gave you a wealth of information. The least you could do is sit back, use whatever relaxing agent causes you to be calm. Unlike me, I have to have about 14 gallons of... Oh, 76.5, we're seeing a temperature increase. Very slight. A little more. I like to live on the edge. Tell her she's got big feet. Your sister's got a nice dress on. Oh, now that's going to do her. That's going to do her. It's holding steady at 76.6. Ah, we're getting a temperature increase. This is where we stop. This is where we stop. That's how you know. That's how you don't get blown to pieces. You stop when you're sure it's going up. Okay? I told you this was a very powerful substance. 76.7, 76.6. Okay, it's not increasing rapidly, but it has increased 0.2 of a degree. We're gonna just... Boy, could you imagine if scientists did this with the Earth's measurement on global temperature? We would probably be in a lot better off shape, huh? I don't know. Who knows? But I can't put any more of that stuff in there. I'm taking it off the table. Keep an eye on this devil. 76.7. 76.8. If we get a runaway reaction, that would be bad. That would be very bad. $76.8. Okay. It's not anything too crazy. Okay. We're going to let it relax. 76.9. That comment about her sister's dress really did us in, didn't it? Really did us in. I'm going to keep an eye on this one. Maybe don't stir it. Maybe stirring it makes her angry. 77. It's a slow increase in temperature. Well, to save you from the bore of it all, I'm gonna go ahead and end the video. I think this has been a great video. the greatest and best. It's 20 minutes long, but I know some of you will have watched the whole thing, and to those of you who did, I applaud you. I commend you. We're going to have a Patreon page soon. That's going to be really great for extra content and rewards and even inventions to be raffled off and such. We're going to keep our eye on this. I'm going to pause the video, and 77.1. I'm going to make sure she doesn't get angry. And I expect this to change colors to a sort of a coffee color, as oxidizers wont to do. And as it dries out, I have to keep an eye on it. It's pretty dangerous, pretty dangerous. Well, thank you guys so much. Have a good evening.